Okay, I want to start with factoring. If there was only one thing that was like the most important thing, it'd be factoring. Because if you go into this test not knowing factoring, there's probably at least 20 questions, at least out of the 60, that you'll get wrong. Okay? You got to know how to factor. And I know you know how to factor, but some of you know that you're pretty bad at factoring. Well, then you should brush that up. Not only will it help you on this test, it's big on next semester, and it's also big next year. It's also big on the ACT. Factoring is huge. So some kids get confused just because it's like too easy. And they get confused on factoring something like that. Would you please factor that? Think what factoring means and factor that. So today we're going to spend a little bit of time factoring, and then I'm going to go through a worksheet, actually 2 worksheets, and I'm going to cherry pick the problems that I think would be the best ones for you to do, and then you're going to do those 2 worksheets with certain problems circled. All right, did you notice that they each had a 2 in it? And you remember my rule, if you can factor it, you should. What you could do is this, 2 times x. Neither one of those can be factored any further, but that 8 could be. Why did I strategically choose 2 times 4? Well, because 1 times 8 wouldn't have really helped very much. AX. Why did I do that? Because now it's really obvious. There's a 2x here, and there's a 2x there. They have a common factor. In fact, it's called the GCF, the greatest common factor. If you left out the 1, you don't really understand factoring. Okay? Raise your hand if you had that right. Why do you need the 1? I mean, couldn't you say, well, you take out the 2x and it's gone? Why can you prove to somebody you need that 1? Yes? Okay. How do you prove this is right? Let's say you're trying to prove to your friend, well, I can prove mine's right. Yes? I think we already did factor it out. There you go. Multiply it back out. Yes, that times that and that times that. And if there was no number here, you wouldn't get your 2x back. All right, good. Next thing. Here's a weird kind of factoring that some people have got down and some people don't. It's called difference of squares. If you know what's going on, you should be like, boom, done. You can't do this by eating a chip. Right, with the finger. Thank you. I don't mind if you eat the chip and write the answer. Did you have x plus 4 and x minus 4? Excellent. Then you probably handle it when it gets a little bit more obscure. 4x to the 4th minus a squared. Just follow the same pattern. What the pattern says is take the square root of this and put it here and here. That would be 2x squared and 2x squared. How many of you got that part right? If you got that part right, you probably get the other part right. Because this is just plus and minus, and then square root of a squared is a and a. There we go. Looks a little weirder, but it just follows the pattern. Raise your hand if you had that one right. Good, move on to the next kind. How about this? X to the 4th plus 2x squared plus 1. Now, that's weird because it's got an x to the 4th. But anytime it's got 3 terms like that, you should just go right to the 2 parentheses and see if you can do it. Actually, really what you should do first is see if there's anything in common on all 3 terms, the GCF. But there was nothing I could have factored out. Like if this had been a 12 and this had been a 4, then there would have been a 2 in everything, you know. I should have started by saying that. So, all right. Did you have x squared and x squared? That's the first step. Then did you think, what number can I put here and here that will give me my 1? Well, it has to be a 1 and a 1. And then they're all pluses in this, so it has to be plus and plus. And then if you're not sure if it worked, you'll multiply it all out. That one would work. Raise your hand if you had that one right. Okay, good. Next one is, what if you have to factor by grouping? Factor that one by grouping. So this is where they get harder, and hopefully you're not going to just say to yourself, oh, well, I got all the other ones, so just because I don't get this, I'll be fine. No, this is actually critical, because in the middle of the really hard problems, you've already done synthetic, and then you have to do this. So it's could be a standalone question, and it could also be buried in the middle of an even bigger factoring problem. So this is going to maybe count you a couple times. That might hurt you not to know this. 3x squared comes out of the first part, the group at the beginning. And then what do I have left? X plus 3. Then what comes out of the next one? 8. Negative 8 is even smarter. Good. If I had done it wrong, these wouldn't match. But if I do it right, they do match. Okay, and then if these are in both of them, they need to be factored out to the front. Technically, you can put it at the end if you want to, but normally when you factor things out, you put it at the front, right? And then, what's left? Oops, sorry. X plus 3, not x plus 4. There we go. And then 3x squared minus 8. Now, at the end, you should really check and see, could I factor it further? This one can't be. But what if this had been a 12? Do you get then I'd be able to factor it further than that? Because both terms would have a 3 in them, you know? Always look to see, did I factor it all the way? Yes? No, it would not. When I factored that 2 out on the very first, at the beginning here, and I factored the 2 out of everything, did I make 2x squared? No, I didn't. When you factor something out to the front, you don't make it squared. All right. All right. So the reason there's kind of 2 of them is that you could take this whole thing and times it by this, and this whole thing and times it by that. That's how there's kind of 2 of them, but you don't say squared. All right. So let's move on to a different kind of factoring. Let's say that we had, how about we go back to that one that we factored, the big grouping one, and then say, well, we know x plus 3 ends up being a factor. Let's do it that other way, where we say, hey, x plus 3 is a factor. So I know you can factor it by grouping, but can you factor it with synthetic? If x plus 3 is a factor, factor it with synthetic. So you do not put a 3 in the box. What do you put in the box? Negative 3. You put the root, not the factor. This is the factor. This is the root. And then I put 3, 9, negative 8, negative 24. Did you even look to see if there was a missing term? You should. Because if this had gone 3, 2, and then it had like skipped over the x and then just gone to a constant, if it didn't have an x to the first in it, for instance, you'd have to have a 0 placeholder. Don't forget that sometimes there's a 0 thrown in to hold a place if there's a missing term. All right, drop it like it's hot. 3 times negative 9. Add them, multiply them, add them, multiply them. Hey, how do I know it worked? The remainder is 0. Then, did you actually interpret this? If you leave it that way on your paper, I mark it wrong, because that doesn't mean anything. It's just a whole bunch of numbers written all over the place. But the answer to this is the factored answer, which would be x plus 3 for this, and if you haven't already done it, write down what that part means. Let's see a couple cell phones on desk. Put them away now. Even if you're not using it, it's not okay to have it out. That's implying I'm waiting for a text. And I think I've told you before, if you really have that situation, like if your dad was in the hospital and you're waiting for news from your dad or whatever, you could tell me that, and I would say it's fine to have it on your desk, but you got to get that pre-approved. Okay, you should have said, this is the x's and this is the x squared. So this is 3x squared. Do I have to put plus 0x? No, minus 8. And there we go. Okay, that's just a review of a lot of different kinds of factoring. And I'm going to give you one really, really nasty one at the very end here. Let me think. No. There we go. Factor it completely. As in, don't just factor it once, factor it all the way. Now, we spent a bunch of time on factoring here. I hope that makes you realize that if you're not good at factoring, you should get help. Like, come in the morning sometime. I am available tomorrow morning if you want to practice factoring. But that doesn't mean if you're good at factoring, you got this final nailed. No, factoring is just the biggest thing that happens. There's a lot of other topics, a ton of them. Factoring is just the one that happens the most. First thought, don't try to make 2 parentheses right off the bat and factor this immediately right off the bat. You'll screw it up. Or even if you do factor it that way, you won't have factored it all the way. You'll get burned by that thing. Where it might have got it something that multiplies out to this, but it's not factored all the way. Who knows what you're supposed to do first? Take a guess. It's okay to guess. I don't expect perfection out of you. Only one person? 2 people? What do you think? Yes, there is a 4 in it. And what do you get when you take the 4 out? 3x? Minus 4. Now, hold on. There we go. Okay. 4, there's a 4th, and then there's a 4 there. Okay, good. 4's everywhere. All right. How do you factor it the rest of the way? You can't. Wait. Does anybody think they have a way that works? If you think it works and you've actually multiplied it out and it works, then cool. But this one wouldn't factor any further. All you could do was take out the GCF. All right, now how about if I tweak it a little bit and I make it so that it will factor further? You can imagine the same kind of scenario, and the kid just got it down to that. And then they go, okay, I guess 4 was the only thing I could factor out. Well, at the beginning, it was the only thing you could factor out. But can you factor it the rest of the way? Did you get 5x squared and 5x squared? Did you get 2 and 2 and plus and a minus? All right. Did you check to make sure that they were factored all the way then? That's got to be your last step every time. Is like, could I factor this further? They don't have anything in common, so no, I can't. Can I factor this any further? The 5 and the 2, they don't have anything in common, so nope. There we go. I'm done. It's factored all the way. Now, what if it said equals 0? Could you solve it and find the roots, the zeros, the x-intercepts? And what if one of them has a square root of a negative in it? What will that make? Imaginary solutions. All right, let's just do that part. Would you please solve this side, and it'll have imaginary solutions in it. It'll be a fraction, and it'll be imaginary. Nasty. Solve that part. Now, some people include the 4 when they're doing this. You should not. You just set 5x squared plus 2 equal to 0. 5x squared equals negative 2, etc. Finish it off. See if you can get it right. X squared equals negative 2/5, and then you square root both sides. And then if you just stop right there, you'd be wrong on like 3 levels. Number 1, it's supposed to be the absolute value of x. Number 2, you get to get the negative out from underneath that root, so it's I root 2/5. And I'm still not done. Because it's an absolute value, that forces the answer to have 2 answers. How many of you remembered to put a plus and minus in your answer? Okay, cool. X is plus and minus I root 2/5. Okay, so that's our review of factoring for the day. That was the topic of the day. Now we're going to go look at some review worksheets in Schoology. So I'm going to pause for a second while we do. So here we are out in the front page of Schoology, and it says Review for Semester 1 Final. I click that, and it's got, I'm in the wrong course. Darn it, hold on. Okay, sorry about that. Here's the right folder for our Honors Higher Algebra class. Semester 1 Final Review, this folder, and there are tons of folders in there. There's one for every chapter that we did. Count them up, see how many there are. How many chapters are there that you're going to get tested on? 7 is correct. These 7 right here, your 7 folders. Now, I'm going to divide it up since we basically have today, Wednesday, and then tomorrow's Thursday, and the next day is Friday of review. But there is one more review day after the long weekend. I'll use that too, but I'll use that for kind of like cleanup. I'm going to do 2 each day. I'm going to do these 2 today, these 2 tomorrow, these 2 the next day, and that leaves this guy out. Why do you think I'm leaving it out? You just got tested on that like a couple days ago, okay? You need to know those. They're fresh enough in your mind that you should be okay. Now, what if you're not? What if you bombed that test? Then that's part of, when I assign you a few things to do today, it's going to be on the smallish side. So that's where you'd beef up with, well, I bombed this test. I better go look in there and do some of the practice problems that are in there. Okay? All right. So today I said we were going to do those top 2, functions final review and transformations final review. So I'd like you to start with, open up the functions final review. Within that, notice that there's a review and the solutions is right underneath it. Do you get you can use that very powerfully to like, oh, I don't remember this. Go look at the key, see how the teacher worked out, and then don't just copy it down. Stupidest thing ever. You're trying to learn this for the test. Look at what the teacher wrote. Try to learn from it so that you understand how to do that problem. It's very few points worth when you, as far as the doing one problem of a homework assignment, but get a problem on a test wrong, it's a much bigger deal. All right, so I'd like you to grab this worksheet, and then I'm going to download it so that I can just have it be bigger up here. And I'm going to circle certain problems that I want you to do, and I'll do some of them with you. And then does that mean you can only do those problems? No, you can do all of them if you want to. I'm just going to suggest that certain ones are probably enough for the average kid. Sad thing is everybody thinks they're above average. But you know what? In this room, you can't all be above average. You could be above average nationwide. That is actually possible. But within this room, half of you are below average for this room. So my point is, I'm not saying you're bad people. I'm not saying you're terrible at math. You're in an honors class, and most of you are really smart. But you can't just say, oh, I'm really good at math, so I don't need to do any extra practice. Some of you will be fine with how much I assign, and some of you should probably do extra problems. All right, let's start by doing this one. We're going to do this one, and let's see if underneath my little recorder thing, yeah, this one, another good one. Those 4, I'm going to start with, there's more, but, and let's just start with the easiest of them all, the f of 2. What does that mean? Stick 2 into the f function, which goes right there, and I get the square root of, do it in your head. You can figure out what you get for an answer. And if all you do is write the answer, you miss the point. You're supposed to have some work. I'm going to at least do some of it in my head. I stuck a 2 in, and 2 plus 2 is 4. So square root of 4 minus 3, which would be 2 minus 3, which makes negative 1. The idea there? Simplest of them all. How about this? Where do you start on D as in dolphin? You start on the inside. So I need to figure out G of 0. So that's the first thing. And once I figure it out, I'll stick it in here. Let's say I figure out G of 0 is 7. I put a 7 then, and I do K of 7. I'm not saying it is 7. I'm saying you should figure out what it is and put it there. All right. How about this kind? K of H of X. Whoa. Well, since they didn't tell me what x was, what is h of x? Because I got to put it right here. So what is h of x? Well, it's right here. So all of that goes right here. And that means we do k of that. What does that mean? That means you stick all that stuff in the k function. K of that stuff, so you stick all this into k, which means you'd stick it in there. So your final answer will be 2 over a whole bunch of stuff, which you need to simplify. All right, some more I think you should do off this page. Circle those if you haven't already. A, D, E, and F. When they do this, it gets more confusing. We're doing K and we're doing M. Because if it's got extra stuff in here, I've always told you to do it this way. Scribble that out and do it one step at a time. What if it just said F of unknown, mystery? You could call it X, you could call it Q. I don't know what's in there, but F of something is 0. Do you get they didn't tell me the X? So then I got to figure out F of what is 0. Sometimes they give you a chart. Well, in this case, I got to go up here and figure out F of what would give me 0. F of what would give me 0. F of x is 0, is kind of what it's saying. F of something is 0. That's 0. And now I solve it. Figure out what that has to be. Do you get this needs to come out to be a 3 then? So square root of x plus 2 must be 3, so that 3 minus 3 will make it 0. So then how do I make that be 3? Well, it's got to be the square root of what then? 9. So is x 9? X has got to be 7. That'll make it equal 0. Am I done? No, I just figured out that what's in my parentheses, it must have been f of 7. So now I go back down, and I just figured out that this has to be f of, I scribbled it out, f of 7 gives me 0. Do you see what I'm saying? If you don't, there's a video for this. I know you're like, are you showing me the video right now? There's actually going to be a video for, like for almost anything you could ever want. I've recorded them all and put them at davidserver.com or at servervideo.com. You can go there, take a look at the site, and then in the search bar, you could search for this topic, which is functions. All right. So that was one of the tougher skills. Let's move on to another one I'm assigning. Q as in quirky. Math is best done one step at a time. What's k of 2? If I could figure that out, and let's say it came out to like 10, then I'd know it was just 5 times 10 plus 1. I just got to figure out what this is. So just, in this kind, figure out what k of 2 is. Go up to your functions, find the k function, stick in a 2. It's not tough. And you'll figure out what the k of 2 is. Do this first. Then once you got that number, you do this next. 5 times that number, and then do this last. Why? Because I'm following the order of operations. The thing had parentheses, it was on the inside, would do that first. Then it has multiplication with the 5, so that's next, and then the adding is low as last. Okay. Now, we got to get to the bottom part of this worksheet. We're going to do a few off of this section too. I'd like you to do the first one with me, A, and then I'm going to assign also E and F. If you want a challenging one on this one, you should try H. That's an optional one. Okay, what's F of 0? Well, on this kind, you're supposed to ask yourself, did they tell me X or did they tell me Y? Because I got to go look it up on this chart over here. And I'm looking for a point X comma Y. So what did they tell me, the X or the Y? The X. They told me X was 0. So here's where X is 0 is, right there. Now I follow it up, boop, to right there. And what's that point? What comma what? 0 comma 1. Now, do you get that means f of 0 is 1? Don't forget that's what a point means. If I give you the point 2, comma 5, that means f of 2 is 5. That's what a point means in terms of function language. Okay, so I just figured out the point was 0, 1, so f of 0 is 1, and that's what they wanted. F of 0 was 1. All right. Here, did they give me x? No, they told me f of x. What's f of x also known as? Y. So they told me y is negative 3. Stay with me, you're drifting. Y is negative 3. If y is negative 3, I go to my chart. Here's where y is 3. Oh, negative 3. Here's where y is negative 3. I follow it over. This is where the line would be, that negative 3. And, oh, it hits right there. So I'm going to say what's that point? Negative 3, comma, negative 5. And then I'm smart enough to know that f of negative 3 is negative 5. See how making that point into it, it gives you the answer? Look at what I just wrote, and look what the question is. F of negative 3 is negative 5. You get how that lines up with this? So it's saying f of, I'm going to write it right underneath it, and maybe you'll see it then. F of negative 3 equals negative, screwed up. I just did f of, sorry, I wrote the point down wrong, and everything after that was doomed. Negative 5, comma, negative 3, and then f of negative 5 is negative 3, and then I'm going to rewrite that over here. F of negative 5 is negative 3, and that should tell you that, oh, x has to be negative 5. The f's are the same, the negative 3's are the same, the equals are the same. The only thing is, oh, x must be the same as negative 5. All right. So I suggest you do A, E, F, and H. Now on the bottom, the one kind with the chart. Better do a couple of those. Let's do the first one together just to kind of get the hang of these charts again. This one, A, f of negative 1. Here's the f function. And then they told me x is negative 1, so that means I should go down this column. And then the answer's 2, because that's where I found it on the chart. I recommend you also do D and E. You could do all of these, but I don't want to assign too many. So, okay. I'll help you just a little bit with D. If it says G of 0, I just go find G of 0, and I got a number, and I put it there. And then I find f of that. This is the harder kind. G of f of x. What is f of x? It's all of this stuff. When is all of that stuff 0? All right, so that can be your challenge question. All right, so now I'm going to move on to the other worksheet. That was just one of the 2 worksheets, but I know, honestly, some of you are already done with that worksheet. As I was assigning them, you were doing them. So now let's go to the other one. I'll pause while I pull it up. Okay, it's in the Transformations Final Review. Transformations Review worksheet right there. Opening that guy up. And I got to download it. I'll pause while I do that. Okay, so there's my worksheet. And here's the ones I'd recommend doing here. You should do number 1, number 2A. And on this page, I'll just get started. The equation for this one is y equals x squared. I hope you know that parent function. But it's been transformed. That's why it's called transformations. It's been transformed as in it's been moved. So I'm going to make this x squared a little bigger so I got room to put stuff inside it. It went to the left 1, which seems like it should be minus 1, but it's really plus 1. It's one of those themes. On the inside, it's the opposite of what you would think. And then it moved up. Can I trust that? Yeah, the stuff on the outside you can trust. Now, one more thing. The hardest kind here were stretches. Do you remember those? If it goes over 1 and up 1, almost every parent function should go right there, over 1 and up 1. They all go through the point 1, 1 on the original graph, and therefore, almost every, I want to just say almost every because the circle, for instance, doesn't go through that, but almost every parent function goes through 1, 1. So if you look over 1, up 1 from the vertex of it, then there should be something there. If there isn't, then it's been stretched. And then you got to figure out which way did it get stretched. So let's say it had gone here instead. And I'd be like, well, there's supposed to be one here, but it's actually twice as high. Oh, so therefore it'd have a stretch factor of 2. This one does not have a stretch factor. All right, here. I recommend you start on the inside as you describe how it was transformed. And you do the stuff on the inside in opposite of normal order. There's only one thing on the inside here, so it's easy. Write 5. And then you do the stuff in the order of operations. On the outside, you trust that order, and you do the normal order. And that would be multiply by -1 first and add -8 last. So that's a reflection. And then a last thought on these, horizontal on inside, vertical on outside. Hi-vo. Does that ring a bell? Because they're going to be asking you stuff like, is it vertical transformation or a horizontal? All right. So I know I'm going really fast, but I'm also trying to cover an entire semester in 3 days. So that has to mean I have to go incredibly fast, especially since I had to spend some extra time on factoring because that's so important. All right, another one I strongly recommend you do here is number 4. If you want more practice, of course, you could do this one too, but that's optional. On number 4, it's one of these functions, and I don't know what the parent function is. Kind of looks like absolute value, but it's not because there's no arrows on the ends. So that's not absolute value. I call it f of x. I don't know what it is, so I call it f of. So when you don't know what function it is, you put an f there. Then you say to yourself, how do I describe how it got moved? It got moved down some and over some, and so like, this is wrong, but let's say I would say, I think it got moved that way. So you write in what the actual right answer is. Yes? No, because you don't know what the original function is. So you say f of x has been changed, so I take f of x, and then I say, I want it to say it moved to the right 5, that's totally wrong, and moved up 2, totally wrong, but kind of like that. Okay, and we move to the bottom page, and these plain old-fashioned graphing, 4 distinct points. Now you can do this by graphing the parent function, which goes like this, and over 4 and up 2, and over 9 and up 3. I just don't like it very much because then you got to take every point and stretch it, every point and flip it, every point and move it. You know what I mean? I got to do 3 separate things to every one of those points. So I personally think it's smarter to make an XY chart. Also, because it works for every function. I don't even have to know what this looks like. If I forget what x cubed looks like, I can always just make an XY chart. Otherwise, you got to memorize every parent function and all the dots on every parent function. It's a lot easier to just learn how to do an XY chart, and it also works the next year in pre-calc. Because we get functions you don't know how to do, but you can always go back to the XY chart. Now, I don't want to just pick willy-nilly. Like if I pick 1, that's really dumb, because I have to do the square root of 3. So what's a good thing to pick? 2. And if I put in a 2, then I can get square root of 4, which is 2. 2 times -3, -6. I can guarantee you then that 2, -6 is on this graph. Now, when I'm done with the graph, if I'm done with the graph and it looks like this, then I did something wrong. Because, you know, I know what a square root looks like. It kind of looks like this. So I hope this thing sort of looks like a transformed ramp. So if it comes out with your dots in the wrong spots, then check your XY chart because you did something wrong. But I think the best combo is you do an XY chart to get some dots, and then hopefully you will see your ramp shape. Oh yeah, my ramp shape got flipped, and it got moved 2 to the left, and it's stretched higher than it used to be. I'm a big believer in the XY chart. I also believe you should know what these parent functions look like. So let's take 2 seconds to go over them. The square root, that looks like this. The x cubed, that looks like this. What are some other biggies you got to know? The quadratics, they're parabolas. They look like this. How about the x, let's see, 1 over x function? That's the butterfly. Remember what that one looks like? Kind of like that, because I think that sort of looks like butterfly wings. Anyway, you can call it whatever you want. That's some of the big parent functions that people forget. And then let's move down. And I'm finish off the last few that I think you should do. I think you should do number 9. And I think you should do number 14. That's the last one I'm going to talk about. It's the circle. Do you remember the parent equation for a circle? It's not like y equals x. It's totally different. Can anybody pull that up? I can tell you this. It's one of the top most missed questions by Minnetonka students, probably nationwide too, but on the ACT and PSAT, circles. It's one of the reasons that it's smart to review this kind of stuff from time to time, because you could be really smart, sit down for the ACT test, and like, I don't remember the equation for a circle. There goes the point. So, can anybody pull it up? That's actually kind of close, believe it or not, but you're wrong. Yes? Yep, but hold on. All I want to start with is the parent one. So if the parent one looks like this, what's the equation for that? I'm going to just simplify what you said and just say this. You are correct, but I want to clean it up a little bit and make it even easier. X squared plus y squared equals, well, wait a minute. It can't have a radius of 0, though, right? I think it should be the radius squared, which would be 1 squared. There we go. So there's a good start. Now, has my circle been changed from the parent circle? Yeah, it got moved to the right, and it got moved down, and it's bigger. So how do I actually make my final answer for this equation? I start by making more room. And what's the radius in this case? So I can say radius squared. Radius is 3. So 3 squared. And then it has been moved from its center being at 0, 0 to being over 1 and down 2. I'll let you finish that off and check it with the key, of course. Yes? Can anybody verify that I signed those or not? She asked about if I did work on them, then I'm assigning them. If I did work in the problem, I am assigning the problem. So 7 and 8, if I did work on them, that were meant to be assigned. Okay, and there's a whole lot more on this worksheet. Oh, I guess there is one more that I've assigned in the other class and I should assign in yours. Just one more. And that's this guy, A. Do you remember functions that look like little squiggles or whatever, and you got to move them and stretch them and that kind of stuff? There's 2 ways to do this. I personally think the best way is you make a little XY chart and you figure out what the parent points of the original one are. In this case, it's 3, 0 for that point. This point is at -1, 4 for that point. This point's at -3, 1. And this point's at -5, 1. And the first thing I would do is graph the parent one on over here. And then I would do this stuff to it. I would make it get moved to the right 3. And then I would make every one of the heights, that's on vertical on the outside, that's all the vertical stuff, all the heights twice as big. So you can make the heights twice as big by just taking their y's and doubling all of them. You can take the x's and move them all to the right 3. You might think you would subtract 3 from everything, but it's always the opposite of what you'd think. So I add 3 to all of these. And then I graph it. Okay, so there's my advice for the first 2 chapters. Tomorrow we'll have more time than this because I did that big factoring thing at the beginning of today. But those are the problems you should do tonight. I am not exactly certain yet how I'm going to have you Dropbox this / show it to me in class, etc. But not only is it going to help you on your test, but I am going to assess it somehow. It might be as simple as this. On the day of the final, have each kid walk up, show me the worksheets that you did leading up to the final. And if they're like blank, blank, you know, like, okay, obviously you're going to not get points. And also, not a great idea to make a bad impression with the teacher right before they have to make the final decision. What final decision? Well, when I'm making the call of your grade is an 89.4, what do you need? 89.5 to get A minus. Okay, and you're just really close. And then kid didn't do the practice I told them to do for the test. They didn't even try hard. Why should I give them extra points when they weren't even trying? So, the point is, I do judge your effort. And that gets taken into account on things like this. Do your stuff. I cut it down a lot, right? I could have just said, you know, do all those problems. I tried to make it reasonable, and you need to do your part. Okay, that's all I got for you for today.